So in the previous videos, we looked at frequency tables, but in this video, we're going to take a look at relative frequency tables or relative frequency distributions. And relative frequency distributions are based on the frequency. So you'll see that the two are related. So frequency, this column here, represents the count. So how many students completed between 9 and 31 credit hours? 15. How many students completed between 78 and 100 credit hours? That's 4, et cetera, et cetera. And if I sum up this column, it's going to add up to 53, which is my sample size. So when we talk about relative frequency is the proportion of your data that falls into each class or each category. So what I'm looking for is I'm looking for what proportion of all the data that I collected falls between 9 and 31 credit hours. Well, to figure out what proportion, a proportion is just some part out of some whole. So the part is there were 15 data values out of 53 that were between 9 and 31 credit hours. So we call that ratio or that proportion, we call it a relative frequency. And you can display your relative frequency as a fraction, but typically in statistics, we display relative frequencies as a decimal taken out to 3 decimal places. Okay, but there are times when you might want to report your findings as a percent. So we know that we can always translate a decimal to a percent by multiplying it by 100. So this is telling us that out of our 53 data observations, approximately 28 of them were between 9 and 31 credit hours. And then you just continue on. So 15 out of 53 completed between 32 and 54 credit hours. So that's 0.283. And again, you can think of that as a percent as well. So 28.3%. 13 out of 53 completed between 55 and 77 credit hours. So that's 0.245 or 24.5%. And then 4 out of 53, which is 0.075 or 7.5%, and 6 out of 53, which is 0.113 or 11.3%. Now, if we sum up our relative frequency displayed as a decimal, right? The sum of all of these values needs to add up back to the whole being 1, okay? Now, if you translate it to a percent, then obviously the percent should add up to 100%. Now, if it doesn't add up exactly to 100%, that's just due to rounding errors because we did round our decimal to just 3 decimal places. Okay, all right, so just like how we created a frequency distribution, we can create a relative frequency distribution just as easily. So a relative frequency distribution, the x-axis is going to have the same exact labels as the label that we created for the histogram for the frequency distribution. So again, I'll have 8.5 up to, what was it, 8.5 up to 31.5. And then we'll have 31.5 up to 54.5, then up to 77.5, and then 100.5, and then 123.5. And the only difference between the histogram for the frequency distribution versus the relative frequency distribution is the labeling on the y-axis. So here, I would call it the relative frequency instead of the frequency. So the labeling is not going to go from 0 to 15, but it's going to go from 0 and at most to 1. All right, so here I'm going to graph, so that's approximately 0.5, and then we've got approximately 0.25 here. So here is 0.283. So our first graph is going to look like this. Our first relative frequency bar is going to go up to 0.283, and then this is going to be 0.283, and then 0.24, and then 0.7, and then about 0.11, okay? So again, you'll see that this looks a lot like the frequency histogram. The only difference is the scaling on the y-axis, okay? All right, let's real quickly talk about what a cumulative frequency distribution is. So again, a cumulative frequency distribution, we can display it in a table, but we can also display it as a histogram. I'm going to just show you the table, and I hope that you can see that we can also translate this into a histogram just as easily. So when we're talking about cumulative, cumulative means the sum of all the frequencies in the data set up to some point. So here, I want to take a look at how many students completed up to 31.5 credit hours, and that was 15. How many students completed up to 54.5 credit hours? Well, that's 15 plus the previous 15 from the first class, so that gives us 30. Right, how many students completed up to 77.5 credit hours? Well, that's 13, but then plus the 15 and the 15, so that's 30 plus 13, which is 43. So notice that it's accumulating as we move down each class, okay? So how many students completed up to 100.5 credits? Well, that's 43 plus another 4, so that gives us 47. And then up to 123.5, well, that's 47 plus another 6, which is 53. And notice that we end up with our sample size of 53, just as we would expect.